Welcome, gang. I forgot to start recording on the 29th lecture. Anyhow, we did. Who's chatting right now? I know. That's good. Fired. Well, that's what Trump used to say on his TV show. You're fired. Anyhow, we did an example to help you with homework, and we're doing another one now. So this is true for any j, this inequality. -1 to any integer power is either 1 or -1. So since j to the 4th is always positive, we can divide each piece. And the inequalities are the same. So that is -1 over j to the 4th has to be less than or equal to -1 to the j over j to the 4th is less than or equal to 1 divided by j to the 4th. So if you remember way back in Calc 1 when we used the squeeze theorem, this was how we used it. We needed a way to construct an inequality where the thing we're interested in is in the middle, and on the outside we have two things that we already understand. We know how this behaves. We know how this behaves. And so the squeeze theorem says we take a limit. So yeah, sure. Go back. Sorry. Do you have a question or you just copy? Yeah, you're allowed to say, slow down, O'Grady. Good. All right, so now the next step is to take limits. So we take the limit of each piece. The limit as j goes to infinity of -1 over j to the 4th. We know that has to be less than or equal to this limit. And that has to be less than or equal to this limit. But we know the outside guys are just 0. That's 0. And we are trapping the limit of interest between two zeros. And so the result follows. The only number that's simultaneously between 0 and equal to 0 is 0. So logic says there's only one number that limit can be, and it has to be 0. And of course, if you went to a calculator and raised it to a large number, you're going to get 0. So let's do that for fun. Oh, excuse me. I think I did that on camera and recording. I'm so itchy. I can't believe I didn't shave. What a loser I am. Well, then it wouldn't work. The only thing you could say is it's between 0 and 4. But notice, so the question was, what if one of these was like 0 and this was 4? Well, that wouldn't do you any good. The idea is to build this inequality in a way that you get it trapped between 0. How did I figure it out? With a 0 and 4, how would you figure it out? Well, that would mean what you did doesn't work. It's not figuring anything out. If you got it between 0 and 4, you didn't do enough. You didn't work. You didn't solve the problem correctly. Or you wouldn't have proved it. You would have deduced something that the limit was no less than 0 and no bigger than 4. But that doesn't tell you what the limit is. I think a good example of that is on the midterm, that problem with the integral, and I broke it into pieces. All we told you was that it converges and it was trapped between 0 and some number. We didn't tell you what the number was. So sometimes that's useful, but here we could actually tell you what the limit is. And the reason we were able to is because if we come back here, we started with this, which is always true. We I educated guessed to divide everything by j to the fourth. Why did I guess that? Because that gives me in the middle what I want. And it just so happens that when I do that, this piece and this piece go to 0. Does that make sense? Yeah. All right, so very good. The next thing we want to do is look at the second type of problem that I had on the homework. And that was, and we'll do part 2A together, and then we're going to build on it to move on. So let's compute the first 5 partial sums of, and we've actually already did this. We just didn't put it in this thing. A few classes ago, we did this. First 5 partial sums of this series. Which is 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus 1/64. So what is the first partial sum? The first partial sum is just the first number. The second one is the sum of the first 2 numbers, which we can get as 3/4. The second one is the sum of the first 3 numbers. But we already know, so this is 3/4 plus 1/8, which is 6/8 plus 1/8, which is 7/8. So notice I'm not using decimals now. It doesn't matter. You could use decimals if you wanted. So these are the first 3. Does anybody have a question about these? Yeah.
So that symbol you wrote over here, right? Is those ones are connected to the symbol?
I'll say that again.
The symbol you wrote, right?
The sum?
Yeah.
What about it?
Those straight lines are connected to them?
These things right here?
Oh, yeah.
Yeah, that's just, I mean, I guess I could write that a little cleaner. Are you talking about just the style that I'm doing it?
Yeah.
I mean, some people write it like this. That's one way of doing it. Some people put these here. Doesn't matter. Is that the question you had? Yeah. Yeah, it's just sort of my way of doing it. Okay, so these are the first 3. Does anybody have any questions? We need 2 more. Now, by the way, there's a pattern you can note here. I don't know. What do you mean? Why would I be adding 1/16? That's the 4th one. 1/16 is the 4th term. So I can't, the first, here's a way to think about this. So this guy is S sub 1. The first 2 is S sub 2. The first 3 is S sub 3, etc. Does that make sense, Emily? I don't think I made an error. Okay. Now for the next one, we'll add the 1/16. And by the way, there's a pattern you can notice. What is the pattern that makes this? You can be a lot quicker if you notice the pattern. This is always, notice that these 2 right here are just S sub 2. And so if I notice that pattern, then I can come over here and quickly do the last 2. S sub 4 is just S sub 3 plus 1/16, which becomes 7/8 plus 1/16, which becomes 14/8 or excuse me, 14/16 or 15/16. And then S sub 5 will be 15/16 plus 1/16, or excuse me, 1/32. And what do you get? Well, that would be 31/32. So there's a real nice pattern hidden in here. Look at these answers. Notice since I didn't write them as decimals, I can see a beautiful pattern. You don't see it yet, but I see it. Maybe you do see it. There's a beautiful pattern. And I'm going to show you this on the next page. So in general, what do we have? I wish I was a prophet. I wish. So here's a beautiful pattern. So it looks like S sub n is equal to 2 to the n minus 1 over 2 to the n. That's what it looks like. I mean, check it. Just check for yourself. Let's say S sub 4. S sub 4, let's just use this portal. We get 15/16, right? Is that what S sub 4 was? Yes, it was, right? Now, notice I use the words looks like. Just because it works for the first few doesn't mean it's actually true. We got to verify this. Can we verify this? So if this is true, then S sub n is equal to 2 to the n minus 1 over power 2 to the n, which is the same as 1 minus 1 over 2 to the n. And beautifully enough, the limit as n goes to infinity of S sub n would be equal to this limit, which is 1 minus 0, which is 1. So again, there's some very important words that I have here. First off, I said looks, and then I said if. So if what we think is true, then this reasoning follows. But we have to verify. We need to verify this formula for S sub n. And we're going to do it in a second. It's not difficult to do. It requires some cute algebra.
So you just separate in 2 parts, right?
How did I go? Are you asking how I went from here to here?
And you separated them, right?
Yeah. I just broke. Think if what the best way to think about what I did is move right to left. If you wanted to combine them, you give them a common denominator, right? The reason I like to write it like this is because then it's a lot easier what the limit is. Oh, so then all we have to do, and by the way, what would this mean? And this means this quote unquote proves what we claimed classes ago. And that is 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1 over 32nd. If we did that until the end of time, it would equal 1. Yay. So this is fun. At least I think it is. You might think I'm crazy. I didn't ask you to, oh, that's a good question. For the homework, I did not ask you to do this yet. All I asked you to do for the homework that's due tonight, All I asked you to do is just do the first 5 terms. Do this. So it's just arithmetic for homework, nothing else. That's a good point. So if you pull up the homework, it's only asking you to do the first 5 partial sums. That's it. Okay, so what happens is it remains to show that S sub n is in fact equal to 2 to the n minus 1 over 2 to the n. Here's how we're going to do it. So to do this, we compute something. What we're going to compute is we're going to compute the following. I want to compute 1/2 times S sub n. Now listen, I know because I paid attention when I was a kid that if I have an apple and I cut it in half and I give Shobit half of it, how many do I have left? I have a half, right? So another way to write a half of something is to write it as the whole minus a half. So again, I'm getting cute here. I'm writing the half of something as whole minus half of it. Look, S sub n is a number. Anytime you give me a positive integer n, say it's 42, I can compute S of 42. So I know it's a number. And the other thing I know is that half of that number is equal to the whole minus half of it. Now you might say, why are you doing this? Well, because I am going to take advantage of this pattern that I recognized here. I recognize the pattern. I recognize that S sub n is equal to S sub n minus 1 plus a term. And so what I'm going to do is I want to look at trying to subtract. And this is one way that I can subtract things. And I hope that if I subtract it in a creative way, I get a simple formula. So this is not a trick. This is a method. This kind of thing that we're going to do works in lots of different places. It doesn't just work in this problem. What we plan on doing is writing S sub n out and then taking half of it and subtracting them. And then we're going to write half of it in 2 ways. So we have 1/2 S sub n, but what is this equal to? Well, this is S sub n, which is a half plus a fourth. Now, this goes all the way out to what? 1 over 2 to the power n. Now I'm subtracting 1/2 times S sub n, which is 1/2 plus 1/4 plus dot, 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 plus 1 over 2 to the power n. And so if I do some arithmetic, this is 1/2 plus a fourth plus all the way out to 1 over 2 to the power n. And then this becomes minus a fourth, minus an eighth, minus a 16th, minus a 32nd. And then this goes all the way out to minus 1 over 2 to the n, minus 1 over 2 to the n plus 1. So that you might need a sort of a little bit of a moment to make sense of that. So I'll remind you what I'm doing is I'm distributing this negative 1/2 to all the terms. Now, why does this trick or method work? Well, look what happens. Everybody got a partner now, except 2 people. The very first term and the very last term don't have a partner. Everybody else got a partner. So if I take another color, say green, I say, okay, this guy and this guy, bye. And then the 8th's going to have a partner right here. This guy's going to have a partner. This guy has a partner. Everybody has a partner but the first and the last. That's right. But the beauty is, it's like the ugly duckling. Even though the first and the last don't have a partner, they're the only ones that survive, and they get to make all the magic happen. because what is left is 1/2 minus 1/2 to the n plus 1. That's it. I like this. I like the fact that you guys give it back. Right, so that's the next step. So before we go to the next page, I want to point out what we've just done. We've showed that half of the apple, this is half of the apple is equal to the whole apple minus a half. And so if we follow this reasoning, what we get is half of the apple was equal to 1/2 minus this phrase or this expression. So that is the conclusion. What we get from this page is the following. So we conclude that 1/2 times the number s sub n is equal to 1/2 minus 1/2 to the n plus 1. Or by multiplying by 2, you get s sub n is 1 minus 2 over, well, we can write it out, the whole damn, we'll write it out, make everybody happy. We don't want to skip steps. If I take 2 to the other side, I get 2 times 1/2 minus this. And now if I distribute, I get 1 minus 1/2 to the n as claimed. So that is verification. So yeah, you're right to point that out, Safalgar. There is a clear pattern here, and everybody might see it differently. But what we've done is we didn't just recognize the pattern, we verified it using logic. We didn't just say it looks to be true, we showed you it's true. Yeah.
Where did the 2 December from the last one?
What do you mean the last one?
2 multiplied by 1/2 n plus 1.
Well, what's if I have a 2 upstairs and I have n plus 1 downstairs? What are your exponent properties? So I think, are you asking what happened to this 2? Okay, so when you do this, this would become 2/2 minus 2/2 to the n plus 1. And so this is just 1. And then there's a 2 upstairs and there's an extra 1 downstairs, so they cancel. So this 2 cancels with that. Exponent properties, does that make sense? Now, what's really good about this is this argument that we just did, we showed it's true for 1/2 to the power n, but it's true for a lot more things. Okay, so let's summarize what we've done. Summary. We proved that this series converges to 1. That's what we proved. Now, more is actually true. And we can, I'm not going to go through it, but I would highly, and I mean highly recommend you try to do it on your own. So we can modify the proof above to prove a more general result. So this type of series that we just studied, this 1 divided by 2 over n, this is a very special type of series. It has a name because of its patterns, and we're going to tell you about that right now. Does anybody have a question? Comment? Does anybody want to ask anything? Like, what's everybody doing this weekend? What kind of partying we having? What kind of homework? We working? I don't know. Studying math? What's that? I can't hear you. What? Am I voting? Yes, I will vote. You should all vote if you can. You probably aren't allowed, though. We'll get you an illegal ballot. That's what the Republicans always say, right? They say that the Democrats cheat. It's like, I can't wait for this election to end. Those 2 jabronis are going to have a debate tonight, but apparently they're going to cut their microphones off so they can't scream and yell at each other. Good God, what a time to be alive. Halloween party, there you go. What am I doing, Mike? That's a good question. Well, tonight I will probably watch the Looney Tunes debate, and I will probably have to have adult beverages to calm my nerves as they scream and yell at each other. Don't drink unless you're 21. I'll probably get together with friends. Oh, it's funny because in my group of friends, there's like Republicans, there's MAGA people, which is so weird, and then there's people who ain't MAGAs. Yeah, 21. This is America's fault. You got to play by the rules, dude. I don't care what the rules are elsewhere, right? You have to wait till you're 21. Isn't it so funny that the drinking age is 21? It's like one day, if you're 20 years old and like 364 days old, you're not old enough and mature enough to have a drink. But hot damn, when you wake up the next day, you're now responsible and you can have a beer. I never understood that. Well, I'm sure you did. In most cultures, they let you drink. Although that's an interesting thing. I've often debated that one of the reasons we have such issues with drinking and stupid things in the United States is because it's considered such a taboo thing. Like everybody tells you don't drink, it's bad. And then you get older and then everybody gets drunk as hell. I mean, Emily, she was telling us that she was, you were like the first week of class. I said, what'd you do this weekend? You said you drank what? What was it? Ain't no laws when you're drinking the claws. Whatever the hell those weird things are everybody drinks. Trulies, no. Saturday, I watch football on Saturday and Sunday. I play basketball Saturday mornings, and then I'll go home and watch football, and then Sunday watch the Steelers and hang out with the crew. We throw bags all day and drink beer. No, drink Kool-Aid. We drink Kool-Aid. I'll do math too. I like to do math. Yeah, American football too, not soccer. Hell yeah, tackle football with helmets, not soccer. All right, this was fun. See, I have fun. This is good. They sure did. This is exactly right. So this is what you guys are missing without having a true O'Grady experience. If you were all in here, we'd have way more of these stories and fun times, right? Okay, Zafalgar, when does anything we do make sense, right? Right? I mean, we don't even use the metric system. That's why most of our students suck at arithmetic in the United States, because we're asking them to do weird bases instead of everything by 10. Right? We don't. Precisely. That's right. Anyhow, yeah, but this all started with voting. Yeah, we will vote. You should all vote. I don't even care. Go write me in. Don't write Kanye in, write O'Grady in. I'd be a hell of a president. First thing I would mandate is you guys ain't allowed to use any technology until you understand how it works. That would be the rules. So you couldn't go to Wolfram or what's that one Simbo lab you guys love? You guys love, think about this. You guys love things that give you answers. What fun is that? What the hell fun is the problem? You know, if everybody gets the answer. That's like if Lydia says, let's build a puzzle, Dad, and then I did it all for her. What the hell fun is that, right? What happened to you guys? You was kids, you loved the challenge. Now you get older and you hate it. That's right. 2024. That's exactly right. A Trevor Noah? Oh my God. Oh, I never watched him. He's like a comedian, right? He makes fun of everybody. He probably just makes fun of the Republicans, though. Did he? I don't want to protest anything. Podcast? I should make math fun again. Well, see, that's the problem. I don't understand, like, these Trump people, like, I see them, like, it's logically unsound. Like, if you're going to like Trump, fine. But you can't wave a flag right now that says make America great again. What the hell was the last 4 years? He was supposed to make it great the last 4 years. Now they fly these flags. It's not logical. It doesn't make any damn sense. Anyhow, I love politics. Although they say you should never discuss politics, religion, or money with good company. And since I consider you all good company, I officially stop talking about politics. I wish all we had was math. Problem is, Emily's, this is a gen, and I don't mean to knock you guys. We suck at math. One thing we are good at, America is good at finding everybody else's smart people and bringing them in, right? That's a good thing. Nothing wrong with that. Okay, this is fun times. I already knew. I didn't say you guys suck. I said in general, as a whole. Very broad, irresponsible thing to say. And I hope you guys realize I'm being funny. I'm mocking the perception. That's all. It is weird how in this country it's cool to brag about being stupid. Did you ever notice that? That doesn't happen in other places, I don't think. Like, or does it? I don't know. Do people back home say I suck at math? I don't know. I can't imagine they do. Like, other people like think, you know, we don't English either. That's for sure. Hey, that's funny you say that. Eric, I was helping my kid with her homework the other day, and Amy got mad at me because she said that I told her to write a sentence and the grammar wasn't correct. And I said, she's in kindergarten. Why the hell does grammar need to be correct? Right? It's very strange. Anyhow, all right, back to math. This is fun. I wish you guys were all here. We'd have a pizza party or something. If the Roni ever ends, we will have a pizza party and we'll get Savulgar to understand the joke of, I don't know what the hell we're talking. This is O'Grady-ish. All right. This is my own English. Ain't. We just make up words. All right. Back to the fun. What is the more general result now? We got to get back to this. It's already 2:50. We did have fun, though. I enjoy this. I'll tell you what. Teaching is fun. The fact I get paid for this is amazing. But I enjoy it. I hope I inspire some of you to want to learn instead of using damn Symbolab for everything. But I digress. All right, look. So here's a very here's a very important thing to consider. Let R be any real number. We call this creature R to the n goes from 1 to infinity. We call this thing, what is this? This is R plus R squared plus R cubed plus R to the 4th plus R to the 5th, and this goes on forever. We call this a geometric series. So this is a very special type of series. So let's just connect it to what we did before. So if R equals 1/2, we get the series we just studied. So if R is equal to 1/2, we get 1/2 to the, let's use K. It's fun to use K too, which is 1/2 plus 1/4 plus 1/8 plus 1/16. Now, before you guys start having an aneurysm, and saying, why is it 1/2 to the k instead of 1/2 to the k? What is the k's power of 1? It's 1. So don't get worked up about how I've written it. Now here's some magic that happens. And this is, I'll tell you what, this is fun. I gotta go check the time. It's so funny. I literally grab my phone to check the time, and I always do this, and it's so weird. I have 2 computers in front of me with the time on them, right? It's amazing what habits are. Habits are a strange thing. Okay, so in general, this geometric series is a pretty fascinating creature because we can verify and prove the following. Theorem. There's 2 pieces to it. If the number r is between -1 and 1, then this series converges. And not only can we show that it converges, we can tell you exactly what the number is. It converges to r divided by 1 minus r. And then the second piece is if r in absolute value is greater than or equal to 1, then the series diverges. So there is a very, very simple formula for convergent geometric series. And we're going to do examples on the next page, so don't get worked up. But it's very, it's fascinating. I would say that a complicated thing, this series, has a simple formula, because that's not always going to be the case. So does anybody have any questions about this? On the next page, we're gonna show you some examples. Okay, so let's just do that. Let's jump right in. We need a new color. Let's get this dark blue. I like this. I like it a lot. So the first thing I want to do is revisit our original example. What is this, the 1/2 to the power k? That's the one we've been doing. And of course, let's write the first few out. That's 1/2 plus 1/4. It's good practice to do this. 1/8. We know this is equal to 1/2 over 1 minus 1/2, which is 1/2 over 1/2, which is 1, as we already showed. So this formula agrees with the example we did. So it might be worth pointing out that here r is 1/2. Let's do a different one. How about we do 3 to the power k now? This would be 3 plus 3 squared, which is 9, plus 3 cubed, which is 27, plus 3 to the 4th, which is 81. This guy diverges. And of course, you want to know why. Why? Because r, which is 3, is greater than 1.
R is always the first one.
Say that?
R is always the first term.
R is always the first what?
Term.
This isn't a sequence, this is a series.
Yeah, like
So yeah, I mean, the first term is always R to the power 1, right? So remember, what does this mean? I mean, this is, look, this is, I think this is what you're asking, and correct me if I'm not. I mean, this is 3 to the power 1. This is 3 squared. This is 3 cubed. This is 3 to the 4th. This is, right?
and the formula we have also here, right? It's your 1 is R over 1 minus R.
Yeah.
That's for all, right?
That's only if R is between -1 and 1. It doesn't work here. This is why it diverges. 3 is bigger than 1. Now, if we go to the next page, let's do another example of something. Let's say the third example. So let's look at this guy. Let's say, how about 5/9 to the power k? K goes from 1 to infinity. This guy would be 5/9 plus 25 over 81, plus 5 cubed. I don't know. Let's say 5/9 cubed, which I don't know what it is, plus, off the top of my head, at least 5/9 to the 4th, etc. This guy converges. And it's not just that it converges to 5/9 divided by 1 minus 5/9. And what is this equal to? This is 5/9 divided by 4/9, which simplifies to 5/4. And so it's worth pointing out, why does it converge? Note, this converges because R in this problem, which is 5/9, is less than 1. Or maybe a better way of saying that is, because that's technically not enough, and it's because that 5/9 is between -1 and 1. So you need this number, this some people call this the ratio, this R. You need that number to be between -1 and 1.
That's a 9, right? Looks like a 4.
This is a 9. This is a 9. Well, no, which one here? This is a 4. So don't, this right here is a 4, this blue one. This is 5/4. Well, this isn't what we're studying. This is the sum. This is the limit. So what you can do is you can write that this thing, even though this is a 5/9 inside, it adds up to 5/4. So yeah, this 5/4 that you're seeing right here, this thing, this is the limit of or the sum of the series. This 5/9 is the R term. You understand the difference there? Mute all. To mute everybody. All right, does anybody have a question about this example? Comment? Now, sometimes, I don't know, he was playing music or something. I think you're playing a guitar. We got to get you to play like one of these weird instruments, like a xylophone or something. Oh my God. Okay. So there's some good news and then there's some bad news now. So the good news is that geometric series are easy to work with as they have a simple formula. Now, I'm going to remind you that it's easy is in quotations. I mean, relatively speaking, they're easy compared to series in general. I'm not saying they're easy for you to learn. I'm not saying that everybody can do them. I'm just saying that in general, they're easy. Now, I'm not going to throw a party. I was joking. I would like to throw a party. The corona won't allow it. I said, if the corona leaves, yes. Yeah. Do that too. Get everything out of the way. And by the way, we should also put simple in quotations. So that's the good news, and we'll write the bad news in red. So in general, there is no such formula for all series.
There is a difference between series and sequence.
Absolutely, yes.
So what's that to be?
I mean, a sequence is a list of numbers. A series is adding numbers up. It's two different things. Series means add, sequence is list. So on your next homework, there's going to be a problem that helps you try to distinguish that at least.
Can we say that sequence, you can find a sequence within a sequence? Is it sequence?
I'm not sure what you're asking.
You said series is adding the numbers, right?
Yeah.
And sequence is the list of numbers.
Correct.
So we can say series is adding up the sequence.
Yeah, you can think of it that way, yeah. But you also need to think about it as a series is defined as a limit of a sequence. So it's confusing. So, right, I mean, you could think about a series as adding up. So the question was, how do we think about sequences in series? And a sequence is a list of numbers. So it's worth pointing that out. So let's note. A sequence is a list, and it has to be an ordered list of numbers. So it looks like this. Let's say a sub k, k goes from 1 to infinity. What does that look like? It's a list. A sub 1, a sub 2, a sub 3, a sub 4, etc. That is a sequence. A series is a sum, and I'm going to put sum in quotations because it's not a traditional sum because it's infinite, but it is a sum. So that means it looks like this. You could take your terms and we ask what happens to each one of these terms in the sequence if we add them. Those are two different things. Does that make sense? Does that answer your question?
Yeah.
Good. Now, even more importantly, this sum, this, why is it in quotations? Because this, when you write either this or this, what you mean is you mean the limit of partial sums. So by definition, a series is also thinking about, you take these partial sums and each one of those describes a new sequence, and you ask what happens to that sequence. So what we'll do is we'll give you some problems and to think about. So before tomorrow and on the next homework, sort of this is what, if you want to learn something, I would encourage you to think about this. And we'll say it in a very cute way, things to ponder. Number one, what characteristics should a convergent series have? So that means if we want to determine what types of series converge, what do we think properties should they have? What kind of characteristics should they have? Ponder, yes, think about it. Yeah, that's right. Hi, Ethan. Your mouth hurt yet? Are you on drugs? I would assume you're all hopped up on Percocets. Here's the next question you should ponder. Do you think this guy do you think this will converge? Why or why not? So one of the things series do is they sometimes play and mess with our intuition. And that's okay, but we need to think of these things. And why do we think it messes with our intuition? Why not? Things like that. So I would encourage you to think about these things after you do your homework that's due tonight, because we're going to talk about. That made me laugh, Ethan. This is true. We shouldn't joke about that, right? In light of certain things. All right, this is a good place to stop. So I hope you think about this stuff. I hope you work on the homework, and I hope to see you either virtually or in person tomorrow. Clearly, not everybody shows up, so I don't think there's any issues if you want to come in person tomorrow. I don't think we need to worry about Group A and Group B. We got plenty of seats in here. Come visit me. We have 2 peasants here right now. That's it. No one else is here. Just 2 legends with calculators. Well, you pulled that calculator fast as hell, Larry. That was so much fun. Anyhow, thank you guys very much. I hope you have a nice weekend. Yeah, well, I know you're late. Turn them in. Yes, you and everybody else. It don't matter if you're private or not, because I popped it up on the screen and everybody sees it. Yell at your friend. Tell them to turn this. Yeah, all right, good. Shobit's going to yell at you. All right, guys, seriously, have a good one. Thank you very much. I will talk to you tomorrow, hopefully. Take care.